Hi everybody, welcome to Stevie's Code Studio. So today's problem, closest binary search tree value. Today I will use two approaches. The first approach is the recursion approach using the in-order traversal to solve this problem. And the second one will use iterative approach. Facilitate the binary search tree's characteristic to solve this problem. And I will put Python, Java, and JavaScript and Golang in my Git and put it in the descriptions. So please like it and please follow to help me to grow. Okay, so let's start. So the first approach is a normal in-order traversal. So first, let's define some variables. This is the minimum difference, and we initialize to positive infinite, and also this is the answer which we will return in the end. Also, we can initialize to positive infinite, and we return. Then we define our recursion method. So DFS node. So before we do anything, we need to clarify these two variables as non-local, because this is a global variables. So if the node is null, then we directly return. This is the termination. And then we do the normal in-order traversal. So first we traverse the left subtree. Lastly, we traverse the right subtree. And then in the between, we do the logic. So first we calculate the difference between the current node and the target. So current node value minus the target. And then we compare if the difference is smaller than the minimum difference. Then we assign the difference to the minimum difference. Also, we assign the current value to the answer. Yeah, this is the recursion function. And there's one more condition here. If there are multiple answers, we print the smallest one. But in the in-order traversal, because first we go to the most left child, which is the smallest one, and then we go back in the ascending order. So the first node we got always the smallest one. So we don't need to compare if the difference is equal to the minimum difference. Okay, so lastly, we need to call this recursion function. Yeah, that's it. So let's run it. Correct, submit. Okay, nice. So this is the recursion approach. And let's go to the second approach, which is the iterative approach. Okay, so let's do some drawing here. The target would be 3.7. So here is the process. We start from the root, so the current root, okay? And then we compare the current node with the target. So right now, the current node diff will be 0.3. This is the min diff, okay? 0.3. And this is the answer. Answer will be 4. Now, because the current node's value is bigger than the target, and this is the binary search tree, so we don't need to go to the bigger node, because if we go to the bigger node, the difference will be bigger than the current difference for sure. So we go to the left child, which is the smaller node. So right now we go to the smaller node, which is 2. So we do the math, and the difference is 1.7. So it's bigger than the minimum difference, right? So we don't do anything, and because right now the current node is smaller than the target. So we go to the bigger one. So we go to the we go to the right child, which is 3. So we do the math. Okay. So the difference is 0.7, which is also big than the 0.3. So we don't do anything, and because the current node is smaller than the target, so we go to the bigger node. We need to go to the bigger node, which is the right subtree, and the right subtree is null. So the process terminated. So the answer will be 4. So that's the process. So let's code up. We do the diff. Okay, so the diff, min diff, we initialize to positive infinite, and this is the answer. Like the recursion, we also initialize, and finally we will return the answer. And the current node will be initially point to the root, while the current node is not empty, it's not null. So we calculate the target and the current node's value, the difference. And if the difference, so if the difference is equal to the if the difference equals to the minimum difference, so we need to get the smallest number, right? So in this case, the answer will be the smallest number among the answer itself and the current node. Otherwise, if the difference is smaller than the mean difference, so we assign the difference to the mean difference, and also we assign the current node's value to the answer. Okay, now we will do the traversal. So if the node's value is equal to the target, so the difference will be 0, of course. So we just assign the answer to, we just assign the node's value to the answer and just directly break the loop. Else, if the current node value is bigger than the target, right? So let's say if the current value is bigger than the target, we go to the smaller one. So we need to go to the left child. Otherwise, go to the right child. And pretty much. So let's run it. Oh, sorry. So this is the current. Yeah, use the current. Okay, cool. Yeah, so this is the iterative approach. Thank you for watching, and please like it, and also please subscribe me to help me to grow. Thank you.